All right. So I want to start with, I'm not just going to give you the formula. I want us to develop it. And we just saw that uh, the volume of a sphere formula can be derived from two cones. So we're going to draw that situation and then come up with a formula that way. So we're going to draw a couple of cones. So draw like you're making a triangle, and then at the bottom, give it a curve like that. And we'll show the back end kind of dashed. And there's our first cone. And then plus, we're going to draw an identical cone, if you can, right next to it. And there's the center. Now, we did talk about the dimensions. They have to be kind of specific. We're going to call the radius r, but the height's going to be, normally it's h, right? But remember, it's the diameter of the sphere. And how many radii are in one diameter? Two. So the height is actually going to be 2r. Um, so I'm just going to say h equals 2r. Okay. And that should equal, draw like you're making a circle, just a circle. And the way we kind of make it into a sphere is we give it an equator, kind of through the middle like this, a little curve. And on the back end, kind of dash like that. That's the part we can't see. And it's also going to have a radius r. Okay. All right. So let's come up with a formula. And we're going to start with what we know. And what we know is the volume of the sphere, of the cone. All right. So let's do that. We have two of them. And over there we have the cone. It's pi radius squared h divided by 3. So we're going to start writing that. Pi radius squared. But instead of h, what do we have for h? 2r. We're going to write that times 2r. And then I'm going to put over 3. I'm going to put dividing by 3 this way. Okay? And then we're going to add to it the identical same thing because we have the same thing over here. Pi r squared times 2r for the height divided by 3. And the thing is, this is kind of messy. We can simplify the numerator in each of these. We can multiply some stuff together. So one thing I can do is, you see the number 2? Since it's a coefficient, it's a number being multiplied. It could go at the very front. Usually that's where we put them. And since we're multiplying, it doesn't matter the order. I can put it wherever I want. The other thing is, I'm going to multiply r squared times r because they're all r's. So if I have r squared, there's 2 of them there. And if I multiply one more, what does that become? I got 2 and I multiply one more, 3. So it's r cubed. It's r to the third. So if I simplify this, this becomes 2 pi r cubed over 3. Plus, I'll do the same thing to this one. All I did was just clean up the numerator a little bit. Okay. Let's do a little more. So now I got 2 fractions, right? Do they have the same denominator? They do. So I can just add them up. Remember, when you're adding fractions with the same denominator, all you have to do is add the numerators. So I have 2 pi r cubed plus 2 pi r cubed. Well, they're identical, right? I got 2 of these pi r cubes here, and I got 2 of these pi r cubes here. If I put it all together, how many pi r cubes would I have? Well, I got 2 here and 2 there. I would have 4 of them. So adding this together, I get 4 pi r cubed. So this is going to give me 4 pi r cubed over 3. Or, this is another way to write that, 4/3 pi r cubed. And either one of these is the formula for the volume of a sphere. 4/3 pi r cubed. And basically we got it from a little bit of algebra here. Okay, so officially the formula is where is that nice purple one? Huh. Oh, okay. Sorry, I'm just looking for a specific. The volume is 4 pi r cubed divided by 3. 4 pi r cubed divided by 3. Okay. That is the formula for the volume of a sphere. Okay. Any questions? All right, let's just do a couple of problems with this. So we're going to find some volumes of spheres. Let's do a basketball. So we'll draw a circle, give it an equator, kind of like this. Your average basketball, you're all familiar with a basketball, right? Do you know what the radius of a basketball is? About how many inches would you say? 25.
30.
An inch is about that much, man.
13.
1 inch.
7.
5. 5 inches. A basketball is about 5 inches in radius, 10 inches in diameter. So from the middle to the edge, it's about 5 inches. Okay. So 10-inch diameter, but I'm giving you the radius. Okay. Did I pass the test? Okay. So the radius is 5 inches. Now, this is for a basketball. Let's figure out the volume. So we're going to use that formula, 4 pi r cubed divided by 3. We're going to get both answers in terms of pi and then the exact answer, okay? So let's first get our answer in terms of pi. So we're going to leave the pi as the symbol pi, not as a number. So let's do that. So the volume is 4 pi. We said we'll leave that as pi. Our radius, but our radius is how much? 5 cubed and then divided by 3. Now, let's put this into the calculator. So we're going to multiply all our numbers. 4, 5 cubed, and then divided by 3. So how many times are we going to multiply 5? 3 times. So it's 4 times 5 times 5 times 5, and then divide by 3. Okay, let's do that. 4 times 5 times 5 times 5 divided by 3. And I get 166 and 2/3, or 166 and 6 repeating. And then we just put pi at the end, okay? And this is cubic inches. Okay. That's the approximate answer. I'm sorry, what am I saying, approximate answer? That's the exact answer. What we're going to figure out next is the approximate answer, the one we use in the real world. How do I figure out that one? Yeah, we'll use 3.14. So let's do that one. So the volume is going to be 166.6 repeating. We'll just put a bunch of sixes at the end, times 3.14. And so let's see what that gives us. We'll take this number and multiply it by 3.14. And we'll round it to the nearest hundredth, so 2 places. 523.33 cubic inches. So the volume is 523.33 cubic inches for a basketball. Now, have you ever seen the ball drop in Times Square at midnight on New Year's Eve? You know what I'm talking about? A few of you are looking at me like you never have. So real quick, let me pause this. So the diameter of this Times Square ball is 12 feet. Okay. So number 2, the diameter of the Times Square ball is 12 feet. What's the volume? So what is the volume? Okay. Well, we don't need to draw it because they tell us the important information there, right? Diameter, 12 feet. So what's the radius? And really, for our formula, that's all we need, right? All we really need is volume equals 4 pi r cubed divided by 3. So let's just calculate it using 6 feet. So here we go. 4 pi times 6 cubed divided by 3. So all we need to do is multiply 4 times 6 times 6 times 6 and divide by 3. And we'll get an answer. Let's do that. So here we go. 4 times 6 times 6 times 6 divided by 3. I got 288. Anybody else get that? So 288 pi cubic feet. So to get an idea of a cubic foot, right? A cubic foot is about, this is 1 foot maybe, 12 inches. And then picture one box that size. So if you get 288 of them. Absolutely, go ahead. You need me to open it up a little bit so you can. All right. So 288 cubic feet, 288 pi cubic feet. But we still got to figure out the exact answer. So let's multiply that by pi. 288 times, we'll use 3.14. And let's see what that gives us. Thank you. What does that make? What's 288 times 3.14? 904.32 cubic feet. So now it'd be 904 of those cubic feet. And that's the size of the Times Square ball that falls every New Year's Eve. Okay. How many of you, they're usually maybe this size a little bigger. If you go to TJ Maxx, you buy some really nice ones for cheap. Have you ever heard of bath bombs? Yeah, you know about bath bombs? Anybody not know? They're kind of cool. Zoom this. So number 3 is a bath bomb has a radius of 3.6 inches and dissolves at a rate of 0.5 cubic inches per second. How long will it take for the bath bomb to dissolve completely? Okay. All right. So the first thing we need to find, say this is our bath bomb, is the volume. How much stuff is this made out of? Okay. So this time we don't need this in terms of pi. We want an approximate answer we can work with. So let's just kind of skip that step, okay? We're going to use 3.14 at the beginning. So the volume is going to be 4 times, instead of pi, we're going to use 3.14 times, what's our radius? Yeah, 3.6 cubed and then divided by 3. So let's just put all that into our calculator. You ready? we're going to do 4 times 3.14 times 3.6 times 3.6 times 3.6 divided by 3. Did I do that right? Oh, 195 point. Yeah, I thought the decimal was in the wrong place. 195.33312. Okay, let's just round it to 195.33. 195.33. 195.33. And what's our units? Yeah. Inches cubed or cubic inches? There we go. That's our volume, but that's not how long it takes. It will help us. How do we figure out how long it's going to take, though? They're giving us a rate. They're also giving us a rate. 1/2 cubic inch per second. So how can we work with that? Every second, it goes down 1/2 cubic inch. So what can we do mathematically to use our volume to figure that out? What do you think? We want to figure out, this would give us how many seconds, but how do we calculate that? I think we would divide, right? So what we're going to do is we're going to take 195.33 cubic inches, divide that by 0.5 cubic inches per second. Okay, what's going to happen here is inches cancel with inches, and seconds, because they're in the denominator, they actually go to the numerator. And we get an answer in seconds. So let's divide that. Would you guys divide 195.33 by 0.5? And let's see what that gives us. Okay, well, what are the units for this answer? What's the only units that are left? So it's 390.66 seconds. It's going to take that much time. I don't know about you, but seconds I can't gauge that well. I need minutes. It'd be nice to figure this out in minutes. How many seconds are in a minute? Divide this by 60 minutes, or 60 seconds, in a minute. And this time, seconds are going to cancel, and we're going to get minutes left. So 390.66 divided by 60. What is that? 6 point, what do we get? Okay, let's round it to maybe 6.5. So it's going to take this bath bomb about 6.5 minutes to dissolve completely. There we go. All right. So the assignment today is on delta, and we'll be answering some questions on volume. I'm sorry, not delta, IXL. It's going to be on IXL, and it's finding volume and working with volume of spheres.